This is the last group that we're going to be working on naming, and that is the amines. We're specifically looking at primary amines. We will not be discussing the other types. An amine has a nitrogen with 2 hydrogens on it, and so we're going to see that as our functional group. The general formula is RNH2, and this is known as an amino group. The major property that you need to know about amines is that they are weak bases, very similar to the way that we saw NH3, ammonia, be a weak base. The amines are also weak bases. We kind of lied to you in Unit 3. That was to make it a little easier. For the other physical properties, we will come back to that later. Let's learn how to name them. There are 2 common ways to name amines. The one that we're going to be using is putting the amino as a substituent of the main chain. For this, we want to find the longest continuous carbon chain, pretend like it's an alkane, and just write its name. So it might be methane, ethane, propane. Then we're going to put the NH2 as a substituent of that. We're going to add it in as an amino group, sort of similar to the way we did chloro, fluoro, and those compounds. The difference is that the NH2 does give us the prioritization of determining the direction of counting. So we'll put that on. We'll count the direction so that the amino group gets the lowest number it possibly can on the chain. And finally, we add in all of the other substituents, indicating which carbon number each one is on, recalling that the direction of the numbering will be determined by the amino group because it must get the lowest number possible. That's the directions. Now let's practice. As usual, we start by finding our functional group. Here we see a nitrogen, and so that tells us that this is an amine class of compound. So we're going to call it amino, and then we say the length of the chain, and that is methane in this case because there's only 1 carbon. The nitrogen would be on carbon 1, so we would normally write 1-aminomethane, but in this case we do not need to have the 1 because it can only be on carbon 1. That's letter A. Letter B, let's look at it. We see our amino group. Again, we don't see the hydrogens listed here, but they are there on this one. Those dashes mean hydrogens. We have an amino group. It has 2 carbons on the main chain, so this is aminoethane. And we're going to put it on number 1, but we do not need to write the 1 because this one is a short chain. It can only be on carbon number 1. And finally, letter C. Here we see our amino group. We put in amino, then we follow it with the main chain, which is 4 carbons long, and we get aminobutane. Now we need to determine which number the amino group is on. So looking from the forward direction, we'll get number 3. In the reverse direction, we get number 2. So we would put 2. Do I need it this time? Well, yes, because if I put it on the end, it would have been 1-aminobutane. That means the number is required. I have one last one for you to try. Now, I'm not an artist, so do the best you can with my drawing here. And we'll put an NH2 on it. Now, what would you call this? Wait for it. Anybody got it? That's right. It's amino world. Sorry about that. There aren't too many organic jokes, so I had to do it. And finally, we'll draw our amines from a given name. So let's draw amine A. It is 2-amino, 3-chloro, 5-fluoro, 2-methylpentane. Notice that these groups are done in alphabetical order, not numerical order. The numbers fit with whichever carbon they're upon, but it's always written in alphabetical order, including the amino group. We always start at the end, so we see that this is an ane, which just means single bonds. It doesn't tell us the group yet. In front of that is pent. That means that there are 5 carbons in our main chain. Now we're going to start adding our attachments. On carbon number 2, we have an amino group. That's an N. I go ahead and put in the hydrogens just so that I make sure I have them correct. 3 bonds on the nitrogen, so we're going to have NH2. And then we're going to put on carbon number 3 a chlorine. On carbon number 5, we're going to put a fluorine. And back to carbon number 2, we're going to put a 1-carbon chain methyl group. And that is our carbon skeleton. We just need to add in our hydrogens, making sure that carbons get 4 bonds. Nitrogen has 3 bonds. If there was an oxygen, we'd put on 2 bonds. And that the hydrogens and the halogens each get one bond. And that is our structure. Let's try letter B, where we have 2,4-diamino-5-pentyldecane. As usual, we start at the end. We see it's an ane, means everything's single bonded. There doesn't seem to be a special group here, but we'll go ahead and work from there. We see that it says decane, which means there are 10 carbons in the main chain. So we'll draw out those 10 carbons. Then we'll go to carbon number 2 and we'll put in our first amino group. And then we'll go to carbon 4 and put in our second amino group. And finally on carbon 5, we'll put in a 5-carbon chain because pentyl says 5. And that is our carbon skeleton. Next we need to add in our hydrogens, putting 4 bonds on every carbon, 3 bonds on the nitrogens, and that's all we have to work with here. And that's it for naming and drawing amines.